folks, I want to take some time to talk about systems of linear equations in three variables. I know that's a mouthful to say. You know what systems are from a previous section. That's when you have more than one equation that you're trying to solve, and the solution or solutions that you're trying to find make every equation true. So not is it just a solution to one equation, but a solution to multiple equations. Now, linear equations, you know, that creates straight lines. Well, this time we have something brand new. We have linear equations in three variables. So not only do we have an x and a y, like we did in a previous section, but now we have an x, a y, and a z. So we have a third component going on. And what I've got here is an example for you. So you see there are three variables, an x, a y, and a z. There's also three equations. So the number of variables needs to equal the number of equations to be able to find a specific solution. And what would that solution look like? You know, when you're solving a system of just regular linear equations with an x and a y, you're talking about two-dimensional space. You're talking about a point of intersection. Well, it turns out a linear equation in three variables is a graph of a line in space, okay, because we have that extra z component, and it's going to be the intersection of these three lines in space. And there's a visual for you. So you're finding the point of intersection of these three lines in space, and you can see it's an intersection of the planes, of three different planes here. Okay? Now, the first question I want to ask here is 5, -3, -2 a solution to this system? How could we possibly tell if 5, -3, -2, which is a point in space, a solution to this system? Well, remember, this is an ordered, I can't say it's an ordered pair, right? It's an ordered triple. So we're going to take this ordered triple and substitute it in not one, but all three of these equations. So let's break this down. 5, -3, 2 really means x is equal to 5, y is equal to -3, and z is equal to -2. So let's go ahead and substitute that into the first equation. So x is 5, so I'm going to replace the x right here with 5. And then there's a plus, and then it says y. I'm going to replace that with -3. Another plus, again, right there in the equation, z, which is -2. Does that actually equal 0? And you just do the work. So we know 5 plus -3 left to right is 2. 2 plus a -2 is 0. And yes, 0 equals 0. So we can say the point 5, -3, -2 is a solution to the first equation. But is it a solution to the system? So let's move on to the second equation. To help you out a little bit, I'm just going to write the second equation down. You may want to do this as well, so you don't make any copying errors. So notice this exactly as the second equation is written. Remember, I'm replacing x with 5 plus 2 is part of the equation. Y is -3 minus 3, and z is -2. Now we're trying to see if this is true. We don't know that that's equal to 5. We're just checking. Careful with your order of operations. You know you must multiply before you add or subtract. So this is 5. Plus 2 times -3 is -6. And then minus 3, you think about that as a -3 times a -2 if you like. That makes that a +6. Does that equal 5? It sure does, because these two guys cancel out for opposite signs. Hey, so far so good. We've got our second equation checked out. Now check the third one. Again, I'm going to recopy that third equation exactly as it is, just to avoid any errors. And you can see I'm plugging in. I'm going to plug in for x, y, and z. So I have 3. My x is defined to be 5 that was given in the problem, plus 4 times -3, and then plus 2 times -2. Does that really equal -1? We're going to find out. We have 15 plus 4 times negative 3 is a negative 12. You could write that as plus a negative 12 if you like. Plus 2 times negative 2 would be plus a negative 4 or minus 4. Does that really equal negative 1? Well, 15 minus 12 is 3. 3 subtract 4 is negative 1. And we could say, ha, it works for that one too. Now, what does that mean? Is yes, the point 5, negative 3, negative 2 is a solution. So that is where these three lines intersect in space. Got another problem for you here. I highly encourage you to pause the video, work this problem out on your own. Notice I ask the same question. Is 4, 1, 2 a solution to this system? So pause, work it out, come back, tell me what you think. All right, so to do this problem, you know what I'm going to do? I'm going to plug in x is equal to 4, y is equal to 1, and z is equal to 2. It's an ordered pair. It will always be in that order. X, then y, then z. I'm going to plug those values into all three of these equations. So x minus 2y is equal to 2. Is that really true? Well, it is now, but when I plug in the values, is it true? So 4 minus 2, my y value is 1. Does that really equal 2? And it does, right? 4 subtract 2 is 2. So it works for the first equation. Second equation, 2x plus 3y is equal to 11. When I substitute 2 times my x is 4. My y is 1. I got a little carried away with my parentheses there. Let's try this again. Plus 3. And again, my y is equal to 1. Is that really equal to 11 on the other side? Well, I have 2 times 4 is 8 plus 3. Sure is, right? Works for the second one. It's going good, right? So third equation, negative x plus y minus 4z. Does that really equal negative 7 when I plug in those three values? So negative 4 plus y is 1 minus 4 times z is 2. Does that really equal to negative 7? Well, I've got negative 4 plus 1 minus 8. Negative 4 plus 1 is negative 3. Negative 3 minus 8 is negative 11. Does that equal negative 7? No. No. And you know what I would do? I would go back and check it again just to make sure, because we all make silly mistakes. I know you find mine. They are there. So if I plug in negative 4, I'm checking that I wrote the problem down. I'm checking that I plugged in the correct numbers. And it still doesn't work when I checked it again. So what does that mean? Well, it worked for 2 of them, but not the third one. It is not a solution. Okay, it's not a solution. Now, if this was just the first 2 equations and we didn't have that third equation, then we would have ourselves a solution. But this is not a solution. Must make all three of these linear equations true. Okay, so far we've just checked solutions. You want to learn how to solve these things? Well, let's do it. Now, there's more than one method for solving linear equations. Matter of fact, there's entire classes on solving linear equations, but the method we're going to use is eliminating variables. And I would say that's probably the easiest method to learn to solve linear equations. Number one, we're going to reduce the system to 2 equations and 2 variables. And notice this is, I'm just reading, this is usually accomplished by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. Okay, now you've heard me in other videos, and I may use these interchangeably. You have the elimination method and the addition method. Y'all, they're the same thing. So if your book calls something the addition method and your teacher calls it the elimination method, don't worry. It's the same exact thing. And there's usually 2 methods we're going for. The substitution method, which I've always heard called the substitution method, and the elimination or addition method. So this is called elimination, but you may hear again it called addition. Why? Because right here, addition method to eliminate the same variable. Okay? Now, step 2, then what? Solve the resulting system of 2 equations, because step 1 is going to give you 2 equations. and two variables using addition or substitution. That part's your call. You learned how to do that in the previous section. The result is an equation in one variable that gives you the value of that variable. Next step, you're going to back substitute, which is exactly what you did when you solved systems with two variables, which was two equations and two variables, okay? And then step 4, use the values of the two variables from steps 2 and 3 to find the value of the third variable by back substituting into one of the original equations. And finally, step 5 is going to be to check your work. I know it takes time to check your work, but that's what we did in the first two problems that we did. It is listen, these take a little while to do, so it is worth the 30 seconds, 45 seconds, minute and a half that it takes to check your work to guarantee that you did the problem right. So let's follow these steps and do our very first problem of solving a system. So real tiny over here, you'll notice that I have the steps for you, almost falling off the screen, but it's enough there that we can get this done. So it says reduce the system to two equations and two variables. This is usually accomplished by taking two different pairs of equations and using the addition method to eliminate the same variable. Okay, hard to see here, but look, eliminate the same variable. Same. I cannot stress that enough. The same variable. So I'm going to work with the first two equations. Let's write them down. X plus y plus 2z is equal to 11. And the second equation, x plus y plus 3z is equal to 14. Now, what variable do you eliminate? How about the easiest one, right? Honestly, it doesn't matter. You can eliminate the x's, you can eliminate the y's. It would be a little more work to eliminate the z's because of those coefficients in front. Here's how I'm going to do it. I'm going to multiply the entire top equation by a -1. Why would I do such a thing? Because that's going to make that negative x minus y minus 2z is equal to negative 11. Second equation I haven't touched. X plus y plus 3z is equal to 14. Check your work when you do that, because if you make a mistake early on and you do a whole lot of work after that just to find out you made a mistake, it's frustrating. Now you can use the elimination or the addition method to add down, okay? So you see why I multiplied by that -1, right? Because the negative x and the positive x cancel. That was my goal. Well, I kind of get a bonus out of this situation. My negative y and positive y also cancel. Is that bad? No, it's great. Negative 2z plus a positive 3z gives me 1z. I'm just going to write that as z equals 3. Now, unexpectedly, we went ahead and got one of our results from the first elimination round, okay? And remember, our goal was to eliminate x's. We've only worked with two equations. Which equation have we not worked with? The third one, right? We haven't worked with the third one. So you are allowed at this point to either work with the first and the third or the second and the third. It does not matter to me at all. I think I'm just going to work with the second and the third. So I've got x plus y plus 3z is equal to 14. So that's the second equation. And x plus 2y minus z is equal to 5. Now notice if I add down right now, no variables will cancel. So I'm going to have to do something similar to what I did on the first equation, or the first pair of equations. And I'm going to multiply one of these guys by 1, or -1. So my x's will cancel. So is there anything wrong with multiplying the first one by -1? Not a thing. So I'm going to rewrite, y'all. So negative x minus y minus 3z is equal to -14. Second equation, x plus 2y minus z is equal to 5. Notice I didn't change the second one at all. Let's add down. You want to? So, negative x, positive x cancels. Is that all right? Yes, that's what we were trying to do. Now, my y's don't cancel. Is that okay? Absolutely. Negative y plus 2y is 1y. Negative 3z plus a negative z is minus 4z equals negative 14 plus 5 is a -9. Here's what I'm supposed to do next. I'm supposed to work with this equation that I've circled and this equation over here, okay? Now, this is fancy because it just came out to be an answer, which helps us out a little bit. If I'm solving these two, well, these pair make a system. I already know what Z is. Y'all, I'm just going to plug in Z. That'll help me find Y, won't it? So I'm going to have Y is equal to, not equal to, my bad, careful. Really easy to make silly mistakes when you write all this stuff out. Y minus 4 times Z is 3 equals negative 9. I'm just substituting that dude right there. Why? Because I'm trying to solve a system with these two equations, and since I already know the answer to Z, let's just plug it right in. That gives me Y minus 12 is equal to negative 9. I'm going to solve for Y by adding 12 to both sides. That gives me 3. Hey, I've got two results now. I have a Y and a Z. Now, we're finally at this point right here. We have got two answers. And you back substitute. So I know that Y is 3. I know that Z is 3, provided I calculated everything correctly. So which equation do I plug this into? It does not matter. Pick your favorite. I'm just going to go with the first one because it's first. And I'm going to do it at the top of the page. I'm sorry for work everywhere, but that's kind of how these things roll, especially when you have a little PowerPoint page like I have going on here, right here. So X plus Y plus 2Z equals 11. X, that's the dude I don't know. X plus Y, hey, that's a 3, plus 2Z. So 2 times 3, does that really equal, well, it does equal 11 because we're solving for X. I'm getting ahead of myself. So you have X plus 3 plus 6 is equal to 11. Add your like terms, that's 9. X plus 9 equals 11. Subtract 9 on both sides, and now I've got X is equal to 2. Now remember your answer. I'm going to do this in red so we can find it bottom right of the screen. X is 2, Y is 3, and Z is 3. Now y'all, notice how much room I have left on my page. Not enough to check my work, right? But you should absolutely check this work. If I plug that back into the first equation, X plus Y plus 2Z equals 11, so there'll be 2 plus 3 is 5, plus 2 times 3 is 6. 5 plus 6 equals 11. Yes. Okay, now that's not a surprise that it works on the first one because we use the first one to solve for the X value, but you need to check the other two also. So I'm going to try to do this in my head. So I have 2 plus 3 is 5, plus 3 times 3 is 9, 5 plus 9 is 14. Hey, it's looking good. And then let's check the third one. How about you pause the video? You check this third one on your own and let me know. So I'm hoping what happened is you have 2 plus 2 times 3 is 6, so 2 plus 6 is 8. 8 minus 3 is 5. Sure enough, I know my 2, 3, 3 over here is my solution. Remember, that is the point of intersection for these three lines in space. Now, before I shut this video out and start a part 2, why don't we go ahead and do a second one of these to make sure you're feeling pretty good about it. I have quite a few just to make sure you understand how to do this. If you feel like, hey, I got it, and you want to go on and do the homework, you jump right in there. But I do a few more just in case you're having issues with this, and there are weird things that can pop up for sure. All right, what do we think about this big old guy? Okay, so 2x plus 3y plus 7z is 13. Now you can read it. Let's go through the steps. So I'm solving these two at a time. So I'm going to rewrite, better yet, let's talk about what's best to eliminate. I'm only looking at the first two right now, y'all. These two equations. Now, the question you ask yourself is, do I want to eliminate x's, y's, or z's? Does it really matter? Not in this problem, because all three equations have x's, y's, and z's. So just go with what's easier. Well, all of them have coefficients too. And if I add down right now, not a thing cancels. So I'm going to have to do some work. So here's what I'm going to do, y'all. I'm going to multiply this first equation. How about by -3? Okay. and the second equation by positive 2. Now, before we jump in there, why in the world did I do that? Well, if I multiply the first equation by negative 3, that's going to make that a negative 6x. The second by positive 2 is going to make that a positive 6x. So my x's will cancel. And you might be thinking, well, that's what you did last time, got your x's to cancel. Hey, it works. If there's not a favorite in there, might as well get the x's to cancel. So this is, I'm going to rewrite now with multiplication. Negative 3 times 2 is negative 6x. Negative 3 times 3y is negative 9y. And negative 3 times 7z is minus 21z. Again, watch your signs. What is negative 3 times 13? Negative 39. Check those twice. Try it again. 2 times 3x is positive 6x. 2 times 2y is positive 4y. 2 times negative 5z is minus 10z. And finally, 2 times negative 22 is negative 44. Again, check that twice, because I'd hate for you to make an error in that step and that mess the rest of the problem up. Now, when you add down, this is called the addition method or the elimination method. I'm eliminating the x's, okay? That leaves me with the equation negative 5y minus 31z is equal to, what is that going to be? All right, how about negative 83? All right. Now, I'm going to circle this equation, not an answer at all, but it's just so I can find it later. And then right to the right here, I'm going to work with the bottom equation and either the first or the second. It does not matter which one you pick, but now here's what you got to do. Because we eliminated x's here, you also must eliminate x's with the third equation, okay? I'm just going to pick the first and the third. Why not? I'm also going to erase this red scratch work over here and work with a different color. How about orange? And figure out how to eliminate the x's. Better yet, let's work with the second and the third. You know why? Because they're right next to each other. If I make those 15 and opposite signs, I've got this. So how about we multiply the second equation by negative 5 and the third equation by 3. Now check and make sure that's going to work. Negative 5 times 3 is going to be a negative 15. And 3 times 5 is going to be a positive 15. So that's going to work out to get our x's to cancel. If this makes no sense, please go back and study the elimination addition method when you're doing equations in 2 variables. That's going to be the ticket right there. So here I go. Negative 5 times 3 is negative 15x. Negative 5 times 2y is negative 10y. Negative 5 times negative 5z is plus 25z. And don't forget the other side. Negative 5 times negative 22. How about positive 110? All right. Third equation, 3 times everything. Okay, 3 times 15x, 5x is 15x. 3 times 7y is plus 21y. 3 times negative 3z is negative 9z. 3 times negative 28. Let me pull out my calculator. And I got negative 84. Again, please be careful with your signs, your multiplication, because this is where simple mistakes, innocent mistakes, just get out of hand. So cancel here. I add, that's 11y. 25z minus 9z is plus 16z. Again, easy places to make mistakes. 110 minus 84, which I should be able to do in my head. But just to make sure I don't do anything silly, I'm plugging it in my calculator. And that is my second equation. Okay. Do you have to organize it just like this? No. But I feel really good when I organize it like this. So what am I going to do? I'm going to stack these up. I'm going to solve a system with this. Now I know you know how to do this because this is what you did in the last section that we covered. Okay, so negative 5y minus 31z is equal to negative 83, and 11y plus 16z is equal to 26. Now, nobody said these numbers are going to be small and cute and fun to work with. They can get much worse than this one, I'm going to tell you. Fractions as answers happen frequently, although I do check my work when I get fractions as answers, just to make sure I didn't do anything silly. Hope this one's not a fraction, but I just don't know. I've got to get either my y's to cancel or my z's to cancel. Have to, okay? I don't see one that looks any better than the other, so you know what? I'm going to get my y's to cancel just because they're on the left, and that seems reasonable enough. How am I going to do that? You know what? I'm going to multiply everything in the first equation by positive 11, and everything in the second equation by a positive 5, because that's going to make that y coefficient negative 55, and this coefficient positive 55. Okay? So then I'm going to come over to the right and rewrite. I could do all this right here, but I just don't want to. I want to see exactly what I'm doing. So this is a negative 55y minus, now 31 times 11 is negative 341. No, fun. Equals, this gets even bigger, 83 times 11, and it is negative 913. Now again, when I get numbers like this, it makes me think I probably did something wrong, but really, probably not. 5 times 11y is 55y. 5 times 16z, we know 16 times 5 is 80. I don't trust myself anymore. I gotta use a calculator. 80z. And 26 times 5 is 130. Okay, what's happening? That cancels out. I have negative 341 plus 80. That's my z coefficient, which is negative 261z is equal to negative 913 added to 130 gives me negative 783. And then, of course, I divide negative 783 by negative 261, and I get 3. And that makes me go, hey, maybe I did do it right. If I got a fraction, that doesn't mean it's wrong, but it makes me feel like I should go back and check my work before I dive headlong into finding x and y. Now, y'all, we've got z. What do we do to find x or y? What do you think we should do? We could read these instructions right here that I'm about to get rid of, because I need the space. Okay, so it is gone now, and I'm going to go at the top of the screen. I'm going to do this work in a different color because all this starts looking alike. So I'm just going to go black, slightly darker, and I'm going to take my z equals 3 and do what? Okay, well, check out these fancy equations we've got circled here. Our first elimination go around. If I take z equals 3 and plug it into either one of them, I like the second one better because there's not negative numbers, but it really doesn't matter. I'll find y, right? So that, that gives me 11y plus 16z. Again, I'm going to plug in z is 3 in orange there for you. Okay, equals 26. And I'm going to solve for y. So I have 11y plus 16 times 3, 48 last I checked. Again, highly encourage the calculator. Subtract 48, so it gives me 11y is equal to 26 minus 48. And I get negative 22. Hey, that makes me feel good because I divide both sides by 11 now, and I get y is equal to negative 2. Now I've got two variables. I got y and z. What do I do next? This is called back substitution. So was what we just did. I'm going to back substitute to an original equation, an equation with x's, y's, and z. I'm going to go with the first one because the coefficients are smaller. So I'm looking at this equation right here. And I'm going to plug in, let's do this in yet another color. How about purple? So we do 2x plus 3. Now remember my y is 3 plus 7. And then what's z? No, my y is negative 2. Whew. See, that's the thing about not doing this in class. I can't have anybody hollering at me that I plugged in the wrong thing. Okay, so y is negative 2. There we go. And z is 3. So 7 times 3. And that's equal to 13. All right. So now I have 2x minus 6 plus 21 is equal to 13. You got a negative 6 and a plus 21, which gives me 15 equals 13. I'm going to subtract 15 on both sides to get negative 2. Finally divide by 2, and I get x is negative 1. Now again, faster than maybe you wanted to do that, but you got those skills already, so I'm not going to stress over that. You know how to solve equations You just need somebody to show you all this big bunch of equation stuff. So how do I write my answer? In an ordered triple, okay? X is always first. So -1, Y is next. -2, Z is last, 3. That is your point in space. It is the intersection of these 3 lines. Do I just type that in and move on? No. Check your work, right? So 2 times -1 is -2. Minus 6 right here is -8. Plus 21 is 13. The first one checks out. Again, I'm just doing this in my head. I don't even suggest doing it in my head. It's just a space issue, right? I'm going to check the second equation, okay? So I'm doing 3 times -1 is -3. Plus 2 times -2 is -4. -3 plus -4 is -7. Plus -5 times 3 is -15. -7 plus -15 is -22. The second one checks out. Now, I know you're capable of checking the third one out, so I'm not going to do it. I'm going to close this video out, and we're not done. We're going to come back for part 2, because I just don't like to make these things so long. Go get yourself something to drink, run around the yard, do whatever you got to do to wake up. Come back, watch the second one. You actively participate. You write these problems down and figure them out on your own, and you don't even have to listen to me. You just fast forward and see if you got the right answer, okay? All right. Come back in a minute for part 2. Have a great day.